On August 16, 2024, SpaceX launched the first space-hardened Nvidia AI GPU into orbit as part of a rideshare mission. The project was a collaboration between the Georgia-based Cosmic Shielding Corporation and Aethero, a company known for producing high-performance space-rated computers. Together, they developed a CubeSat equipped with an Nvidia Jetson Orin NX chip, one of the most popular and cutting-edge AI computing GPUs available today. The technology development of new space electronics is commonly really slow in space. It is in fact not true that the newest and most advanced electronics hardware is used in space, as one might assume. Space radiation, especially ionized particles from solar wind, can strike the electronics inside the spacecraft and potentially damage them. The technical term for this is a single event upset, where for example high energy protons penetrate the satellite's shielding and destroy electronic components. Therefore, space electronics must be designed to withstand high doses of radiation. One way to do this is to manufacture larger electronic components. This way, if a particle hits the chip, only a small part becomes unusable, and the rest of the processor can continue functioning as normal. The damaged area can be shut off, and the other region of the GPU can still be used. As you might imagine, miniaturized hardware can be destroyed with one single hit, making it a no-go in the space industry. There are also other methods to protect space electronics. For instance, if a strong solar storm with many charged particles is expected, systems can be preemptively shut down to prevent damage. Another way to secure computer chips is to insert rapid protection circuits or overvoltage protection with diodes. The most common impact of space radiation, aside from complete destruction of electronic hardware, is erroneous calculation. A damaged section of a chip can produce faulty results. AI GPUs are particularly vulnerable to this, as they have numerous transistors packed into them. If one gets damaged, there's a high chance that others are affected by this. The company Cosmic Shielding Corporation (CSC) claims now to have developed a shielding material that allows miniaturized chips and therefore cutting-edge technology to be used in space. It is a special nanocomposite shielding metamaterial, a kind of polymer interspersed with nanoparticles that stops charged particles. The material called PLA steel can also be 3D printed. The exact composition of the material is a company secret. The company tested the material beforehand in a particle accelerator on Earth and during an 8-month experiment on the ISS. The only goal of the CubeSat mission is the successful operation of the Nvidia GPU, with minimal to no errors. Therefore, only mathematical tasks will be computed on board of the satellite, and the results will be sent down to Earth and checked. However, this approach raises some problems from my point of view. The mission duration is only 4 months. This is probably way too short to check if the technology is really ready for orbital use. Some satellites are in orbit for more than 20 years. Within 4 months, the probability of a significant radiation event, like a single event upset, is relatively low. Even if the GPU performs well, it could be that it simply didn't encounter much radiation in that time, rather than the shielding working perfectly. A related issue is that AI GPUs are only partly needed on spacecrafts. Because of the high cost of satellites, commands to the satellite are sent from Earth and triple-checked before executed. This way, no erroneous commands that might damage the satellite are executed. Therefore, there are not really autonomous satellites in orbit, and this will probably not change with AI capabilities on board. The AI features will most likely only be used to analyze images or for similar tasks. With that being said, if the technology functions correctly and the radiation is completely shielded, the company is likely to see tremendous success. Fast, reliable computing in orbit is in high demand. Direct analyzing and processing of images on board of spacecrafts is currently not done in space. At the time, large amounts of data are sent back to Earth and then analyzed. This heavily influences, for example, the data handling and communication system on board. Also, the weight of the satellite is reduced with smaller onboard computers, not only through the weight of the hardware itself, but also through the structural size reduction of the satellite with smaller components. In addition, with appropriate shielding, the lifetime of the spacecraft could be increased. This innovation could also open doors to space-based data centers, which would enable cloud computing in orbit. The radiation shielding could also be used in human space travel, for example for missions to Mars, where spacesuits are needed against harmful space radiation.